Let's continue with question 4, I think, which is actually very similar to question 3. So hopefully, if you have watched the video for question 3, you can attempt this question yourself. So we once again have to find, excuse me, the equation of the normal. And the normal is to this curve, y equal to square root of x, and the normal is also parallel to this line. Okay, so we need to find the equation of the normal. Let's just start with let the normal be, and this is still a line, so we still have y equals to mx plus c. Now first of all, the normal is parallel to I really need to learn to use this better, is parallel to y equals to negative a half of x plus 4, and that means that the normal and this line needs to have the same gradient. So we know that m, which is in this case the gradient of the normal, would equals to negative a half, and from there we know that y would equal to negative a half of x plus c. Okay, so first thing is easy. The second step is going to be a little bit more difficult. Well, it's not that difficult, it just requires more work than in question 3, is that you need to find the point on the curve that the normal actually crosses, and the tangent, if there is a tangent, will touches. All right, so if gradient of normal, I can't believe I'm writing gradient of normal and not just m, but gradient of normal is negative a half. This means that the tangent must have a gradient of 2, so that when you multiply them together, the product is negative 1. So the gradient of tangent is 2, and this is also going to equal to gradient of, ooh, that's not nice, gradient of y equals to square root of x. Okay, so what I'm going to do is I'm going to find an x value at which this curve has a gradient of 2. If y equals to square root of x, which I'm going to write as x to the power of a half, the derivative is a half x to the power of negative a half, which I'm going to write as 1 over 2 square root of x to make it easy to solve. And we need to solve for x when dy dx equals to 2. So 1 over 2, okay, let's separate the two into two fractions, times 1 over square root of x is 2. I'm going to move the half to the other side. I will get 1 over square root of x equals to 4. So square root of x equals to a quarter. And if you square both sides, you will have x equals to 1 over 16. So this is the x value. At this x value, the gradient of the curve, which equals to the gradient of the tangent, will be 2. From here, I'm going to find the y value. And this point, with this x value and this y value, is going to lie on the normal. Okay, so y is square root of x, which is square root of 1 on 16, which is 1 over 4. So we have 1 on 16, 1 over 4, and from here I can find the y-intercept of the normal. Right now we have this negative half x plus c, so we have a quarter would equals to negative half times 1 on 16 plus c, which means that a quarter equals to negative 1 on 32 plus c, and c would equal to 9 on what? 9? No. All right, not 9. So 1 over 4, and then you have to plus 1 over 32. What's this? 129 on 32 equals to c. Okay, so the normal is y equals to negative a half x plus 129 on 32. Let's hope I haven't made an arithmetic error. So I'm just gonna find the normal at the point x equal to 1 over 16 of this curve to see whether I get the same answer. So normal line. The curve is square root of x, and the point we're looking at is 1 over 16. So 9, well, it is 9 over 32. What did I do here? Oh my god, I'm such an idiot. 9 was correct. Okay, this is what happened when you overthink things. Anyway, so that was embarrassing. Whatever. People make mistakes. So you really should probably not skip steps. I was being lazy for once. And trust your instinct when you do mental maths. That's question 4.